Welcome to solving. I'm going to go over some examples. I'm going to keep it basic for right now, and then we're going to look at everything. We're going to see what are we doing, what laws are we using, what conversions are we using, and how do we do it on our calculator. So I even have my calculator on my computer ready to go, and you can look at what's going on, okay? So let's look at number 10. Number 10, there's nothing extra we need to do. We don't have to divide by anything. We don't have to put anything to the power. We don't have to add or subtract. All we have to do is convert it. We cannot solve it as is. ln of x, well, what's x? We don't know. So we need to convert it to exponential form. What do we remember about our base in exponential form? It is e, okay? E to the 8th power is equal to x, all right? Now, I'm going to go ahead and get my calculator on the screen because you need to see that E is an actual button on your calculator. All right, so here's my calculator, and we're looking at E to the 8th. So I'm going to come down here, all right? I'm going to come down to right next to 4. You'll see the LN button. I'm going to press second, LN, and that's going to give me E, and it's going to make you go up to its exponent, okay? Well, what did we say in number 10? We're looking at E to the 8th power, okay? E to the 8th power. So we're going to go ahead and put 8 there, and we're going to hit enter. 2,980.958. 2,980.958. I rounded that 7 up to 8, okay? So that's how you'd put E into the calculator. Second LN. All right. So 2980.598 is equal to x. All right. That's my solution. Do I have to do anything else? No. That's it. All right. We're going to go ahead and now look at number 11, okay? I'm going to do this pretty quickly. Is there anything extra we need to do? Okay? No, we can go straight into converting. So I'm going to take that base and do 2 to the 5th power is equal to x plus 2. 2 to the 5th power is going to be 16 times 2. Which is 32, is equal to x plus 2. And now we just solve like it's a one-step equation. Minus 2 on both sides. 30 is equal to x. Number 12. Log base 7, 25 minus x is equal to 3. This one, let's check it out. Okay, 7 to the 3rd power is equal to 25 minus x. All right, 7 to the 3rd power, 49 times 7. I don't have a calculator next to me. 49 times 7 is what? 3, 6, 28, 34. So 343. 343 is equal to 25 minus x. Okay, subtract 25 from both sides. 318. When I subtract 25 from both sides, I get 318 is equal to a negative x. Miss, what do we do with the negative x? Guys, it's understood to be a 1, so we would divide both sides by a negative 1. X is equal to a negative 318. Now, you need to check your answer. Will that give you the correct solution? Will it give you a valid solution? How do we check our answers, Ms. Smith? All right. What we're going to do is I'm going to take this negative 318 and this problem right here and plug it back in. How do I do that? You go to your graphing calculator and do log base 7, 25 minus a negative 318. Does that give you 3? It does. So we are good to go. I'm going to wipe this out. Ready? Boom. Look at number 13. in number 13, we begin to have other things in the problem that we need to take care of. If you notice, we have this plus 4 right here and this 3, okay? This 3 and this 4, you need to understand what's happening. This 4 is a constant. This 3 is a coefficient. So when solving equations, what do we do first? We get rid of our constants. So I'm going to subtract 4 from both sides, okay? So this will give us 3 log 2x is equal to 12. Okay? Now I'm going to divide both sides by 3. I'm going to get log 2x is equal to 4. Now does it look like 10, 11, and 12? Yes, there's nothing else going on. We're good. We just need now to convert. Okay? How do we convert? What's the base here? 10. Why? It's a common log. There's no base, so it's understood to be 10. Okay? 10 to the 4th power is equal to 2x. That means we have 1, 2, 3, 4. So 10,000 equals 2x. Divide by 2. 5,000 is equal to x. That is my solution. Not so bad. Y'all can do this. Okay? Now, let's go to number 14. Number 14, we have something in particular. We now have 2 logs. Can we convert with 2 logs? No. Can we solve with 2 logs? No. You guys, we have to solve this. Number 14 is very similar, I think, to number 22 or 23 in your packet, okay, or in your study guide. So this would be a great example to compare on. Now, I know I'm not going to have enough space, so I'm going to go ahead and create a new slide and rewrite this. Maybe, if I can do that. Yeah. And I have to make sure I know what I'm doing. Log x plus 2 plus log x minus 1. Log x plus 2 plus log x minus 1 all equals 1. Okay, so here we go. We have to condense. This is the reason why we learned how to condense, because once we get it to 1 log, we can convert to solve. We always have to convert to solve, you guys. We always have to do that. If we're dealing with logarithms and exponentials, we always have to convert. We cannot convert if we have 2 logs. So we must go ahead and condense it. Well, it's a plus sign. You guys, what property uses a plus sign? Or law, excuse me, what law uses a plus sign? It is multiplication. So, log x plus 2 x minus 1 is equal to 1. All right? Now we can convert. 10 to the 1st power. Oh no, where'd you get the 10? It's common log. It's the base is 10. Okay, you guys? It's 10. The base in a common log is 10. It's understood. Okay? Is equal to x plus 2 times x minus 1. Are we finished? No, we got to now solve. We have a quadratic. So in order to multiply, we can go ahead and use our area model to expand. X squared, 2x, negative 1x, negative 2. All right, so here we go. That becomes x squared plus 1x minus 2. 10 to the 1st power is 10. X squared plus 1x minus 2. How do we solve a quadratic? Well, you guys, we need to subtract 10 from both sides. That becomes 0 equals x squared plus 1x minus 12. What do I do here? We factor, okay? I know you hate factoring. You can do that. I'm going to do it a different color so you can tell the difference. I'm taking this quadratic and I'm factoring it. Negative 12 goes on top and 1 goes on bottom. What factors of negative 12 when multiplied together will give you a positive 1? What are the factors of 12? 1 times 12, 2 times 6, 4 times 3, 3 times 4. Whichever way you look at it, it's going to be 4 times 3. But it's negative, Miss Smith. Well, one of them has to be negative. So, 4 times a negative 3. Why negative 3? We have a positive 1. 4 minus 3 is 1. So, our parentheses become x plus 4x minus 3 all equals 0. Now we can solve. X is equal to negative 4, positive 3. You just check your solutions. You must check your solutions. So, if I take negative 4 and plug it back in, what do I get? Log negative 4 plus 2 is a negative 2, plus log negative 4 minus 1 is a negative 5. Both of those arguments are negative. Do you think you'll get a solution? No! So 4 is not a solution. X is equal to 3 is. That's why. Why? If you plug it into your calculator, you will get an error. Go ahead and try that. Log negative 4 plus 2, what does that equal? Oh, an error. That is how you do that one. I love those problems, you guys. They're my fave. All right. Let's do 15, and then we will move along. 15. 5 is a coefficient, so we need to divide both sides by 5. Do not be afraid of decimals. We've been dealing with decimals this entire time. Don't be afraid. ln 3 minus x is equal to 4 fifths. Convert. E to the 4 fifths is equal to 3 minus x. Okay? E to the 4 fifths is equal to 3 minus x. Now, how do we figure this out? What should we do? We need to put it into our calculator. Please remember, E is an actual button on your calculator. I know I sound silly talking about this, but it's an actual thing. It really is something on your calculator. So here we go. E, second ln E to the 4 divided by 5 equals 2.25 excuse me. Let it catch up. Let my computer catch up. Is it going to do it? Is it going to show you? I don't know. I don't know, you guys. There we go. E to the 4 fifths is equal to 2.226. All right. 2.226. I'm going to go back to what I just saved. Okay. 2.226 is equal to 3 minus x. Subtract 3 from both sides. Okay. That'll give me a negative 1.774. If I'm wrong, somebody please correct me. Divide by a negative 1. Why did I divide by negative 1? There's a negative 1 right there. X is equal to 1.744. Okay? If it's something different with the decimal, please let me know. I did it in my head. Okay? That's how you would do number 15. Number 16. Okay? Look. Same logs. Boop, boop. X plus 2 equals x squared. And then you can solve from there. Alright? The same thing with 19. They have the same logs. You can solve from there. Alright? Okay. Now we're going to move on to solving exponentials. So, let's get some of these done and out of the way. Most of y'all are better, I wouldn't say better, but you're more comfortable with going with this form because you understand how to convert at least this form. So, number 1, we're going to convert to log form. We don't know there is no perfect square to get 59 for 12, so you need to convert that. Okay, so log base 12 of 59 is equal to v. Okay, so when you are doing that, those log base 12 of 59, you need to be able to recognize that that is the correct form. All right, so I'm going to use my phone to hopefully figure this out, and we're going to go ahead and just do it. You'd plug it into your calculator. All right, log base, so you could press math. You'd press math, and then you would divide it. You'd press math, go down to alpha, the A button, and you'd get, when you plug it in, 1.641, okay, is equal to V. All you had to do was plug it into your calculator, plug and chug. The same thing for number 2. Log base 3 of 45 is equal to X. All right, plug it into your calculator, find it away. Not going to go through that. You can check and verify on your calculator. Number 3. This is where you have to do the extra steps. You need to isolate your exponent, okay? You need to isolate your base with your exponent. So I'm going to move this 2 over. 16x is equal to 93. Now we convert. Log base 16 of 93 is equal to x. Okay? You can do that. Number 4. Add 9 to both sides. 2 to the x is equal to 79. Convert. Log base 2 of 79 is equal to x. Again, you need to take it further and actually find those solutions, but I do not have my proper calculator, and I don't want to go through and take a lot of your time up on these equations. All right, so let's scroll down. Hey, I realized that I started writing before you guys were listening, so I want to go ahead and just go through what I did for number 5. I subtracted 3 from both sides, okay, and got 6 minus 3 is 3. 4 times 9p is equal to that number, so I would divide both sides by 4. 9p is equal to 3/4. Log base 9 of 3/4 is equal to p. So, I want you to see the calculator. Let me save this real quick. Okay, so here's my calculator. I'm going to go down to math and go to the A button. Okay, hit enter, and you get the blank log fill in. So log base 9, and I'm going to scroll over, and I'm going to do 3 divided by 4. That is 3/4, is it not? I'm going to hit enter. Negative 0.131. Okay, that is your solution for number, what number are we on? I think 15. Okay, or number 5, excuse me. So number 5 returns with a vengeance, and you have a negative argument, a negative exponent there, which you are allowed to have. So P is equal to a negative 0.1 or 5, whatever it was on the calculator. I apologize, you guys. You would do 6 the same, subtract 5 from both sides. 5 times 14k is equal to 31. Divide by 5. 14k is equal to 6. Excuse me. It's equal to 6. If I can, it's not letting me write. 6 point. There we go. 6.2. No, excuse me. It is 6.02. Okay. You convert. Log base 14 of 6.02 is equal to k. Plug it into your calculator much the same way. All right, that's how you would do those exponent ones. Now I'm going to try and see if they have any with a natural base. Let's see if any of these examples have e. No. So let me come up with an example of what E would look like. Okay, if you are given an exponent example where it's asking you to solve e to the x is equal to 2. So we would have to convert using ln. ln of 2 is equal to x. All right. Again, that's on your calculator right below log. So you just press ln of 2. Now, of course, what happens if you have this, Ms. Smith? 2e to the 3x is equal to a negative 16 or negative 6. Well, divide by 2. E to the 3x is equal to a negative 3. All right? Convert. ln of a negative 3 is equal to 3x. Now, this example wasn't very good because what? You cannot have a negative, so this would be a no solution. Okay? No solution. All right? But it still is the same way that we have been doing it. Hopefully this helps some of you guys. Hopefully you can take your time and kind of pick through this video and figure out what works for you and what does not. The main idea really is, okay, you want to condense / simplify to get 1 log, okay? To get 1 ln log, okay? 1. You just need to get 1, all right? On either side of the equal sign. And then convert. If it's log, convert it to exponential. If it's exponential, convert it to log. And then solve. Okay? Check your solution where appropriate. That's it. Okay? You just have to make sure you understand those 3 laws. You have to understand how to use them. So please, if you don't know what to do, go back to those videos, watch it again, and pick through some of these examples. My key is on Aspen. Please make sure you look at it. And I hope you guys have happy studying time. Bye, you guys.